Eureka! I've got it! So, it turns out, just increasing the spark gap from 8 thousandths to 10 thousandths solved my problem. I just tested it, and it's working the way I want it to work. Now, I could even increase the spark gap more and get even more HF, so that the the tungsten could be even further away before it initiates arc, but I don't want to do that. So, let me show you how it's working now, and exactly what it looks like when it's working correctly. So what you're about to see is I'm going to bring the tungsten in, and you're going to see right when tungsten gets really close, there's going to be a small spark, and an arc's going to initiate without the tungsten actually having to touch the work. All right, I bumped that gap up to 12 thousandths, which I think is the max that it said in the manual that you should set it to. I guess the problem becomes if the high frequency is too intense, it'll start to really interfere with electrical appliances and electronics. Not much change from 10 thousandths. But an improvement over the 8 that I had it set at, where it didn't seem to work at all. So I think I'm just going to live with it like that. Maybe I'll think about rebuilding those capacitors at some point. Alright, so before I close out this video, I'm going to do one more test, and that's to check and see if the start circuit's working. The circuit that's supposed to shut off the high frequency once arc is initiated. So I had to turn on the last couple tests I did, since it was such short bursts. I didn't have the cooler running. So actually, that's the other thing too. I want to see whether or not with the cooler plugged in and running, if that affects the high frequency any. All right. So I'm going to switch that switch on the front from continuous to start. And what should happen is the contactor should close, and as soon as the arc initiates, the spark gap should stop sizzling. Yay! It works. Alright guys, so the next video involving the Airco is just going to be me practicing welding and talking about my experiences with it. Well, I'm back to working on this high frequency thing. I didn't want to let it go. I started thinking about it, and I was reading in the manual, technical manual for the Miller 330, which is virtually the same circuit, about this capacitor down here, which I hadn't tested previously because I knew it wasn't directly related to the high frequency generation circuit, but I read that the job that this capacitor does, let's talk about where it is in the circuit first. This wire right here, which is one of the leads that was going to this capacitor, this wire goes to right on the back of the side of this board. It goes to one of the it's one of the connections that's made to the top of that coupling coil on the actual welding circuit. So if I do a resistance measurement from this wire to the work connection down here, I get pretty much 0 ohms because I'm really just reading that big aluminum coil. So what this capacitor does is, this capacitor C3 on the schematic, which according to the parts list is supposed to be a 10 microfarad at 220 volts AC, is in series with, so this wire right here is the other wire on the capacitor. This wire comes over and goes to the top of this big wire wound resistor right here. So that capacitor is in series with this wire wound resistor, which I believe is designated as R3. And then the bottom end of this resistor, I believe, goes back to the negative side here of the work electrode connection, okay, or in this case the ground clamp when we're TIG welding. So that should be common to the bottom of that resistor right there. I think I can see a wire right here. Yeah, matter of fact, there's a wire, just barely can see it. There's a wire I'm touching with my finger right here. And when I wiggle this wire, I can actually see it wiggling right there. You see it? So that wire comes right down to, and makes a connection right to the back of the work connection here. There's a big cobweb in there I just took out with my finger. So I took that cap out and decided to test it. So this is the back side of the cap, and you can see it's just really got a lot of rust all over it. So I had to hit it with the wire wheel, and all I was able to do is uncover, it says Miller Electric Manufacturing Company, Appleton, Wisconsin, 01-601, which is probably the Miller part number for this cap. And then there's a long, strange number. I think it looks like EUC space 5E. It doesn't really matter. I tried Googling that number. That didn't work. The 01-601 number also didn't work. But according to the parts manual for a Miller 330, C3 is a 10 microfarad at 220 volt AC. I think that that's correct because when I measure this cap, it's actually measuring 7.28 microfarad. So my first thought was, well, that seems on the low side for a 10 microfarad cap. But I know that I've been having problems with this Z meter. My LC102 has been having a problem where it doesn't want to zero properly. What's supposed to happen is when I have the leads disconnected from a capacitor and I don't have them shorted together, you're supposed to hit this button right here. It's supposed to do this. And then you're supposed to short the leads together. So you see now I have the leads shorted together. And you hit this button for short, and I get error 4. And error 4 is value beyond zeroing limit. Check test leads. Well, the problem with that is these are actually brand new test leads. They might not look it because they're dirty, but I did buy brand new test leads and tried the brand new test leads, and it does the same exact thing. So there's something wrong inside the unit here, and I haven't really gotten into trying to figure out what it is. So my point is, since I can't zero it correctly, I'm not positive whether or not it's even measuring correctly. Well, I do have a modern 10 microfarad electrolytic, so let's just see what the meter says this is. Yeah, you see, my meter's saying that this is a 6 microfarad when I know that this is a good 10. So my meter is wrong. But if it's saying this 10 is 6, then I'm not surprised that it thinks this 10 is 7. So then I decided, well, why don't I set it to 200 volts and do a leakage check. So when I do a leakage test at 200 volts, what ends up happening is I get 7.96 microamps, 6.57, and it pretty much drops. Continues to drop. But I'm getting a few microamps of leakage, which might not be much. And let's check the ESR, which is equivalent series resistance of this cap, and just see what that looks like. That does actually seem high to me. You can see it's bouncing around there, but that seems high. So I'm thinking this might not be a good cap after all. So I got to thinking about it, and I was thinking, boy, I was almost positive that I kept spare parts from that other welder besides that coil and the fan and stuff. And lo and behold, way in the back on the shelf behind some other stuff, I had this box, and look what I wrote on the side. Airco spare parts, and voila, the mother load. Here's the extra spark gap that I saved. Even got some knobs in here, some switches, terminal strip. I've got some stuff I may never even need. But most importantly, there is C3, the big capacitor. This one is actually marked even less than the other one. There's like no markings on this thing. So let's see what the Z meter thinks this is. Look at that. 7.5 microfarad. It basically thinks that this one is also only a 7.5. So again, I think the Z meter is misreading the capacitance. I think this really is probably around 10 microfarad. So microfarad value wise, these two caps seem to be testing the same. But check this out. If I do a leakage test on this cap, much lower on the microamps. Watch this, it's going to drop to less than 1. Look at that. So you remember the other one? The other one was around, I don't know, started around 7 microamps and dropped down to around 4 microamps. This one, pretty much staying under 1 microamp. So this cap is not as leaky as this one. And let's see what the ESR is, because remember, we just checked that ESR on my suspect cap and it looked horrible. Yeah, that's still around the same, huh? 15, 1200. I don't know. I don't know if I could trust that. I'm thinking maybe that's the sickness of my meter again. The Auto Z here being ill. Alright. So I figured what I'm going to do is, since I've got it anyways, I might as well sub out this cap with this one and see what happens. So ironically, I was down here today and decided I was going to take this cap out and check this cap. And lo and behold, I went upstairs and my video, part number 8 of the Airco series, had finished uploading, and there were already several comments. And Mr. Scott Henyon, who's been following along with me and probably having some sympathy for me, actually suggested I check this cap. So great minds think alike, I guess, huh? But he also said, make sure I check this resistor, because remember, this resistor is in series with this capacitor. This wire runs right over to the top of the resistor here, okay? And this bottom of the resistor should attach to this wire, which runs right down to this work connection. And it does. You get 10 ohms. So what that tells me is that my resistor here is good. So there's one other resistor in this circuit, and that's this resistor right here, which is directly across this capacitor, and it's a 10k ohm resistor, 10,000 ohms. It's measuring 10.4, so that's good. And this resistor's job is really to just discharge this capacitor when you power down the unit. If this resistor were to open, what could happen is after the unit's shut off, you could actually end up with a stored charge in this cap that then could be discharged at the tungsten electrode. So it's a shock hazard. All right, here goes the first test since I replaced that cap. So I'm pretty sure I can initiate an arc without having to touch the tungsten to the work, but I have to get it so close that it's unbelievable. I mean, it seems like I'm just a few thousandths away. You see the little spark jumping right there? So Scott, I posted a, for all I know, you may have already replied, but I posted a reply to your comment on part 8, and I asked you the question about how far should that high frequency spark be able to jump, because I definitely am generating high frequency, but that spark is just such a tiny little spark. But I mean, maybe that's all you need, I don't know. And maybe I'm wrong to be comparing the kind of high frequency that this thing's made to generate, compared to like a new unit. I mean, I've seen guys showing new units where they've been able to actually just make a spark jump like a half an inch or more. So, anyways, that's where we stand with this thing.